back into this after a few days. I'm going to try and work out where I was. It's always good to walk away from a job and then get busy with something else and then come back and what was I doing? Hopefully I put all the caps back that I'd taken out. I'm pretty sure I did. Don't think I'd have left that hanging, but I guess I'll figure it out when I go back through and edit this. So we've done these two, we've done the main power supply, we've done the 25 mic, which is buried underneath this resistor here. I'm not going to touch any of the mica caps unless I have cause to do so. We'll get any silver mica noise, any crashing, I'll worry about that later. For now, I'm going to work my way through these three. Then I think we'll replace the three later blue ones, and then we should be just about done. I think we'll do some resistor checks, and that should see us ready to actually fire it up and test it again. So for now, let's get this one out. So this should be a 3K, which it is orange, which is 3, black is 0, and red, which is 2 more zeros, so that's definitely 3K. So we'll double check that, see whether we need to replace it. Okay. So out of interest, .8K, so this is definitely high. This doesn't appear leaky at low voltage, which is all this meter can put across it, but that is no excuse to trust it. So I'll be able to test that resistor better now, and that is a 0.05. Yeah, 3.825K, so 3.8K, that is definitely beyond spec. It's 25%. Can't do the math in my head. Sunday, can't do math at all. We go 3K3. Yeah. 328. So just slightly under 3.3, which is good. 0.05. Right, these are big 0.05s, which I got sent to me. I emailed them back and said, hey look, these are monsters. My normal 0.05s, which fit nicely and stuff, are this big. These were the ones they sent. They're both 630 volt rated. I wonder if these were actually failed 1K or 2K volt rated, just relabeled, or I mean they measure okay in capacitance, but this size fits in a lot of places, including my reproduction cat bodies. This does not. So I actually wrote to them and said, hey look, these are not quite right. I'd bought 200 of them, I think. And they sent me some replacements. I said, do you want me to pay for them or send these ones back? They said, nope, don't worry about it. So I appreciate that. That was a Chinese seller too, by the way. Just to fly in the face of everyone banging on about cheap Chinese stuff. I generally have pretty good service out of China. I find that you get the odd rogue seller, but then ain't nobody tell me that there's not rogue Western sellers either. So yeah, these are generally okay. Let's somewhere I've got a block that plugs in that makes testing caps a wee bit easier, but yeah, somewhere. Couldn't tell you exactly where. Every now and then I find it and go, oh, there it is, I must put that out somewhere. And then immediately lose it again. Look at that. 47.02. 47 nanofarad. Okay. Enough whiffle waffle. Alright. Now, the only thing I've slightly screwed up there is I normally like to leave that readable left to right, and I put the resistor around the wrong way. So I can put the resistor that way. That's probably what I'll do. And I think I'm going to wrap that onto the tails rather than try and clean those out. This one looks nice and clean, so it shouldn't be a problem. Once down the bottom, I've left the tails of both the capacitor and the resistor to see which one cleans up the best. That one is taking solder just fine. So we'll trim the other one off. So I don't have a nice little David Tipton tool for doing pigtails. I'm going to do a pigtail here. Alright, now we're quite close to here. Oh, not really, and it can't touch it, but I'm going to feel a wee bit better if I stick a little bit of heat shrink down there. Right, I'll solder that and then just tweak it out of the way. Ah. Guess who? I must have turned the camera on. Now, dumbass, there's the other thing I didn't do. I normally solder the cap to the resistor before I put it in. It appears I'm having a slow start to the day. There we go. So that one's sorted. Right, a couple more .05s. Interestingly different brands, so one of these might be a replacement, at least. This might be original. It's still got spaghetti tubing on it. This one's just quite tight in on that band switch mechanism. Hard to say. If it was a replacement, it was done a long time ago. This one has spaghetti because it really needs it where it's routed. This one doesn't really need it. Could have been what they had in the factory. Could be a replacement. Doesn't matter, it's getting replaced now. One interesting thing to see will be if I can route this anywhere else. This cap here is run to this tab, which is then jumpered down to this earth button, which is the one that the tuning gang is on. There is actually an earthing button down this side directly below, and there's no reason I can see why they couldn't have put that cap in there standing up and onto that tab, which means it says to me that the designers actually wanted it grounded to the tuning gang. I don't know which one it is. It's off that coil, which is the oscillator coil, the modulator coil. It's probably going to be that one there. I don't know what that one does specifically. Occasionally I'm okay with shifting earths. This is RF, and so when in doubt, stick with the original plan. The engineers at Radio Limited certainly knew a hell of a lot more about this design than I did, or do, and probably ever will. So I'm going to snip this out and see if I can just put the 0.5 straight back where this one is. We'll have to shorten that spaghetti, and I may have to lengthen that. I might just fit onto the end of it. So yeah, that's fairly dusty. Been in there a while. Alright, so I've got a standard 0.05 here. I might grab one of my longer ones. I can fit a bigger one in. And because I can fit a bigger one in, it'll reach further. I may as well do it. So yeah, I haven't got a lot to play with, but I should be able to get one wrap on a, not much of a pigtail, but enough of one. Just peel this off a wee bit, so I can get it to move. I may not, I may have to. A lot of times this spaghetti tubing has got some kind of coating on it, whether it's wax or like some kind of lacquer or something, and it doesn't, well, once it's been on for a while, it doesn't like coming off the wire. Plan B. There we go. Yeah, that's pretty mucky. I think I'm just going to replace that. And I think just from the way that's mounted that that's actually the capacitor leg that's run right up through there and down. Soldering onto that tab would be very difficult. This stuff acts like an enormous heatsink. This thick copper braid. I have a big soldering iron for dealing with that, so I really need to come onto here and onto here. Alright, so that should protect that. Alright, put that so I can read it. That end on there. That end on there. Heat shrink to protect it from that shaft. It's not touching anyway. That's in the clear. It's nice and solid. Okay, so that one done. This one, so all I've got to do is get a cap through there in such a way that it's not going to short. I'm going to try and clean those legs of the capacitor before I peel it off. Hopefully that's just a bit of dust, because that leg is looking pretty bad. One thing I do find with these old caps is that actually up by the body of the cap where it's been embedded in wax, the wax often protects the wire quite nicely, and then when you hit it with a soldering iron, the wax melts away and leaves you with nice clean tinned copper wire. So it's often easier to solder right by the body of the cap than it is anywhere else on the leg, which will often be quite badly corroded or just too nasty to actually get onto. 0.05, 400 volt. It's actually been nice. It's nice to be working on one of these sort of mid-30s sets that's so big and roomy inside that I can get away with using these bigger caps. They're certainly nicer to work with in terms of just being bigger, and they're also easier to read because the text's a bit bigger. So having the space for them, definitely going to take that opportunity. One day I should make myself a little tool like Dave Tipton's got. The reality is these pliers work fine for the odd time that I actually do make myself pigtails. I use them when it's appropriate, not always. I know some people love them, some people swear by them. John from Arkansas loves them. I see he's expounding the virtues of pigtails in one of his latest videos, which is good. I mean, they're nice. They're definitely a nice way to do it. I just don't think they're necessary all the time. But I guess having a wee bit of experience to know when it's appropriate and when you can avoid it. It's just about making a mechanically strong joint. That's the name of the game. And that is not what I've made just there. There we go. The other thing is without solder, a pigtail is not a mechanically sound joint. They are in fact quite a loose fit normally. It does require it to be properly soldered as well for it to actually be a decent joint. Whereas J-hooks actually tend to be mechanically strong before you've even soldered them. So, you know, there's that. Right, that's nice and firm where it's sitting and it's not touching anything. If I recall correctly, I did that. Just checking, but I didn't do this one. And that's really loose. There's no solder on the back side of that. Don't think there's much holding this on. Nope. So the serviceman that did these was in a bit of a hurry, I suspect, because that's some pretty lousy soldering. Handy tool. Don't mind admitting I'm getting a bit older, and sometimes something like this just makes life easy. 0.02. Don't know what the chances of being able to get this to focus in any way that you'll actually be able to read it, but that is a 0.02. Let's see if I can work out where it came from. One side of it goes to the volume control. We don't have a 0.02 around the volume control, we've got a 0.01. And this wire then runs through to the phono socket on the back. Alright, please hold caller. I just need to melt my brain a little bit. Okay guys, so I'm just going to interject here while I continue to bimble around in this circuit with my finger trying to figure out what the hell's going on. I spent about 10 minutes tracing the circuit, and one of the things that tripped me up here is that this capacitor is actually the blocking capacitor for the gramophone input, and that's not on the circuit at all. And in my head I believed this capacitor was the one feeding the volume control, and so it really tripped me up. It threw me for a loop. My brain was just not working at all. Now this circuit is different to what's drawn on the schematic, and that's also tripping me up a little bit here, but eventually I get it figured out, and somewhere between understanding what's going on and going, you know what, let's just replace the caps. So I apologise, let's get back to it and do something useful rather than just poke around in the circuit and get confused. Alright, I think I sort of understand what's going on now. Oh my gosh. Let's talk about what we've got. So this cap I've just taken out, this actually runs back to the gramo socket, which is not on here, unless I'm missing something obvious in front of me, but all it is an isolation cap to isolate the gramophone from the circuitry. So 0.02, 0.01 be fine there. So I'm going to put a 0.01 there, a 0.01 there. I suspect that this particular serviceman had a box of 0.02s. Don't really need to do that. People will tell you you do. If the flux is acidic, it could damage the solder joints or eat stuff, but flux in solder is, to the best of my knowledge, not acidic. It's a vanity thing, makes it look pretty, which there is nothing wrong with. You should strive to do this and make it look pretty, but it's not, strictly speaking, necessary. I don't think. I do try and make things look prettyish. Right, I don't think I'm going to reach. Not tidily. Right, let's leave a leg. Alright, nice and readable. Clear of everything. Tidier than it was. 500k back to the cathode. Yeah, it's a weird setup. Well, it's not a weird setup, it's just not, it's not set up the way the schematic says. So, you know, we got wiper, we go back through coupling cap, through a 500k back to the cathode. Wiper goes nowhere but the grid cap. The grid cap actually goes to one end of the resistor on this one. So grid cap comes on here, not via this, not with that. The wiper then comes out, goes through the 0.1, through the 500k and onto the cathode. Yeah, it's not as drawn, but you know, I'm going to trust that previous serviceman didn't screw me, and that this is how the factory did it, and that they knew what they were doing. I guess we'll find out. Okay, one last cap to go. That's the coupling cap. So it's a 0.02, probably only needs to be a 0.01. It looks like in here, looks like a 0.1. That seems wrong. The coupling cap from first audio to output would normally be a 0.01, not a 0.1. I am going to go with 0.01. It looks like the previous serviceman went with a 0.02. Like I said, I think he just had a box of them and that's what he used. There is some weirdness going on here. Some weirdness, but having said that, a lot of the circuitry is pretty forgiving in terms of design and what you can get away with. So, you know, I don't think it's a big deal. Can't get this solder joint to free up. It's another case where there's a hell of a stretch for my little cap. It's going to fit if I put a hook in the very end, a hook into each eye, and I'm going to have just enough wire to do that. Maybe not. Maybe not just enough wire. Maybe just enough wire if I give it a slight tweak. We'll see how we go. I'll throw this in first because it's going to be the easy one. I've got to remelt this again. Nice. The other thing is you don't want to keep heat on these poly caps for too long, because it's not paper, it's plastic inside. And those plastic layers will melt if you get them too hot, which is not ideal. Just make sure that's clear of that leg. Okay, well, unless you can see something I can't, I think that's all the caps done. Nothing hiding down here. These all appear to be mica caps. We're done. Just going to do some spot checks of resistors, and then I'll flip this back over and we'll power it up and test it. Start with some over here. What do we got? So that should be 100k. 115. So we're 15% over. That should be okay, I think. Well, these resistors are 20%, so they're probably fine. Not even sure where that is. Not even going to worry about it. Alright, so that one's okay. This is a new one, I don't expect any problems. Should be 470k. 473. That's good. We've checked that one. This should be 50k. 41, so there's something else across that pulling it down, I suspect. That was in that area of the circuit I don't want to get involved with. So I'll pretend that doesn't exist. So 5 0 and 4 zeros, so that should be 500k. 630, so that's a little bit out of spec. And that is this one here, which provides biasing to the grid. So I think we'll replace that one. I don't know how much of a difference it's going to make. Actually, what do? Do we leave it in and see what happens as an experiment? So 6F6. Right, so fixed bias, minus 16.5 to minus 20. Let's see what that looks like when it runs up, and then we'll decide whether we actually change that resistor or not. We may replace it anyway, but I'm just interested to see what a difference that makes. We've got a 50k down here. Happy with that. We've got a 50k up here, 39, so that's got something across it. Speaker terminal across it, but that's not actually connected. That'll be going somewhere else. What do we got? 10, so that's 100k. $317. What am I missing there? Let's just pull an end off there and then remeasure it. The circuit says 150k, then 150k, and then that goes to pretty much to HT. So we've got 50k, we've got 100k, so that's 150k. Interestingly spread across two resistors, so I don't know why they've done that. Voltage rating perhaps, but this looks like a big one. It should be able to handle the voltage rating on its own. Why? What a waste of tag strip. They run out of 150k resistors. For them to do that, 150k must have been important. But what we've actually got is 350k. So we're well over double what it should be. This one's fine. This one's a mile out. So what do? I could put a 150k 2-watt resistor in and replace both resistors and just come straight up to here. Why are there two? Why have they done that? Why? Somebody tell me why. So confused. It's got to be a component shortage, right? They've just not been able to get 150k resistors, so they've made a 150k resistor. But this is a wee 1/4 watt, and this looks like a 1/2 watt one. So I think I can replace both of these resistors with a 150k resistor, which I have in 2 watt. It should be plenty grunty enough for this particular situation. Go straight up to there. I'm a little bit weirded out by it though. Alright, we're putting 150k straight up there. Okay, 150k replaced. That I think would have been messing with things. That was supplying the plate voltage to the 6Q7, so that 6Q7 was probably running a bit low, if I had to guess, and I am just guessing. But yeah, that yellow wire there runs to here. That's HT, so that is the HT feed for the 6Q7. Okay, so that's that one replaced. A bit happier there. Always check these bigger ones that tend to take a bit of a hammering. If they're bigger, it's probably because they're dealing with more heat, and if they're dealing with more heat, there's a really good chance that they've had a hard life. This one, by the looks of the soldering, may have been replaced. It does look like a more modern dog bone than the others. So it should be a 103, so a 10k. 12.7, so it's ever so slightly high. It's going to be in the power supply somewhere, I think. Pin 4 of the 6F6. Which is the screen grid. This doesn't appear to be wired the same way either. HT, oh, actually it's from the screen grid going to the 6C5 plate. So it's the 6C5 plate, so that should be 10k off HT. 10k off HT. This looks like orange, so 3, 0, and then red, 2 zeros, so that's a 3k. 3.2, that'll do me. That looks like a 2, 0, and then I can't see a dot, so it's probably 2 again, so it's probably a 20k. Hmm. 1.3 ohms. That seems unlikely. Am I measuring that in the right place? Or have we got something else across it which is shorted? What is that? Why is it there? That's our sensitivity switch. Ah, it's our sensitivity switch, which is across our 2K resistor. Let's try switching it the other way, and then we'll measure it. 2.4. So it is a little bit out, but I'm actually not too worried about that. I feel like it's going to not make a huge amount of difference, given that modern radio stations don't run at anything like the power of radio stations back in the day when this was built. I don't think he's likely to ever run this with sensitivity on. He'll want all the reception you can get. If you disagree, let me know in the thing down the bottom there. Okay, at this point, I think we'll fire it up and see what happens. Alright, so we are on dim bulb, and we're going to fire it up. This looks about fine. Our HT voltage is a bit low once it's warmed up. It's coming down to around 150 volts. Perhaps we need a higher wattage bulb in here for a larger valve count. I think that's probably part of the problem here. In terms of signal, I've got the aerial connected to me. That's about where we left it last time. That's good. That is sounding a wee bit distorted to me, and that could be that bias voltage on the output valve. So I'd kind of expect that, I guess. Let's just see what happens when we go full. Oh, that's coming through loud and clear actually. That's much better than we had. Yeah, there's distortion in that audio, so that's something I'm going to have a look at next time. We'll check the bias voltage on there and then play with that resistor and see what happens with that. Other than that, I think we're good here. I think things are okay. So there's that resistor shorted out. Oh, actually, if that's the resistor shorted out, the resistor in circuit, so that 2K resistor in circuit with a sensitivity switch, seems to boost the signal. So I wonder now about how important that 2K value is. If it needs to be in to give us volume, I could try and figure that out. So we may play with that 2K resistor as well, but for now it works. It seems to work a lot better than it did, and nothing blew up, so double thumbs up from me. That's a win. Alright, hey, thanks very much for following along. This has been a long one, but then most of mine are, so if you're still with me, thank you very much. We'll have the second part out hopefully fairly soon. I do appreciate you watching, and any feedback you want to give is more than welcome. See you on the next one.